Now for question number 10, we're looking at the fertilizer industry. Now the fertilizer industry is a lot of reading, is a lot of graphs, it's also a lot of repetitive work that you need to remind yourself. One way that I think would be best would actually to be always draw the structure out for you when you're studying, and then you're able to see what happens, where what happens. Because most of the time, as you can see on my screen here, this is how they'd ask the question. They'll give you so many unknowns. For example, here, I've got raw material, S and T and so forth. So first things first, you need to know the different types of fertilizers that we get and the different types of processes that make those fertilizers. That's very crucial. And once you have done that, I would say draw yourself a diagram for each and every one. You must know the catalysts that are used, what is required, the number of processes, and then you are able to then answer this question. So it is quite a lot of work. Most of the time, it does not count a lot of marks, but this is one of the topics that you cannot fail. For example, if we need oxygen for the reaction, it'll always be oxygen. So you cannot fail something like that. You cannot fail because you didn't read or you failed to remember. So let's see what we're given here. So this is question number 10. And we are told that the flow diagram below shows how fertilizer B, now we're not told what is fertilizer B, is produced in industry. I can see that we add raw material S, we also add raw material T, we don't know what they are. And then I can see we then have nitrogen, and then we've got oxygen. Together, they make process number 1. Now, already that they've written this as process number 1 has a name. They'll ask you, what is the name of process number 1? So you need to know what process number 1 is when nitrogen and hydrogen come together. Now, after process number 1, the nitrogen and the hydrogen will form compound A. Now, we're not told the name or the formula for compound A, so then you need to go back to grade 10 and you need to start thinking, what can form nitrogen and hydrogen? You also need to know the charges that nitrogen and hydrogen will also have on the periodic table. Together they make compound A. We still don't know what is compound A. And then they've given us 2 streams. We can have process 2. Process 2 should also then have a name. But compound A, through process number 2, forms nitric acid. Aha, that's the first best clue they've actually given us. And then through that, I can move through this arrow here and get fertilizer number B. Or from process number 1, I can move to compound A, and compound A can move straight to fertilizer number B. So that's the entire process that I'm given, right? So now let's see what questions follow. So the first one, number 10.1.1, says I must name S, the name of S. Let's go back to our raw material here. So I can see that I have nitrogen and then I've got hydrogen, but S moves in that direction. So they are looking for this one right there. So S will be liquid air. So S will be liquid air according to this diagram. Remember, we still have to figure out what is the fertilizer that they're talking about. This is liquid air. And then it continues to say number T. What will then T be? I can see that T forms hydrogen. So raw material number T must be natural gas or methane. Remember, methane is CH4, and there are H's there that are then taken away. So for raw material number T will then be natural gas. You could have written any one. I don't think the examiner would have been very upset with us. Natural gas, let me just write or here. Or you could have said methane. And now we're very familiar with methane from organic chemistry. Let's look at the next one. We've got 10.1.3. Again, it says name or formula. Now remember, if they say name or formula, guys, you don't have to go draw both or write both. You just need to write one. So now they say we must give the name or the formula of the catalyst used in process number 1. Now we know that a catalyst will speed up the reaction rate by lowering the activation energy without actually taking part in the reaction. So let's see. We've got nitrogen, we've got hydrogen. They're looking for the catalyst that was used in process number 1 to actually get compound number A. And I can already see forming of nitric acid means that one of my catalysts that I could use is then iron or iron oxide. It's also very crucial that you know the definition for a catalyst, but luckily that comes from grade 11, so most of the time then you would have learnt it from them. Iron, or you could have said iron oxide. You can say iron or iron oxide. Okay, let me read it from here, then we'll go back to the structure if needs be. Now 10.1.4, it says we must write down again the name or formula of compound A. Now I know, looking at my diagram, that compound A is what will form when the nitrogen and the hydrogen undergo process number 1, and then we have compound number A. So compound A, and I see, process number 2 forms nitric acid. So compound number A will then give me NH3. That is the compound that will form from process number A. This will be NH3. And like I've been saying, guys, there's a number of fertilizers that you need to know. And for each and every fertilizer, you need to know the catalyst and you need to know what is produced. The only way you can do this is if you draw the diagrams. That's the one way that you can practice so that you know exactly what's going on and what's exactly to come. So let's continue. That was again for 1 mark. As you can see, this topic doesn't really count for much marks, but it's very easy question. So the next one says, write down the name of process number 2. Like I said, the processes will definitely have a name and the examiner will definitely ask you. Because this is fertilizer industry is it's actually a big industry. So process number 2, this is the process number here. So remember, we already found A, which was NH3. We've got process number 2, which is unknown. And then we find nitric acid. Now I can see the formation of nitric acid is actually through the Ostwald process. So nitric acid will form through the Ostwald process. Very, very critical, very, very crucial. They could have asked you sulfuric acid, you would have known the same, would have had to know the same thing. The types of processes, the types of catalysts, and so forth. This one is actually a little bit easy because they only ask you for one. Sometimes they can ask you for all the types of catalysts, so be aware. So for process number 2, what is it called? That is then the Ostwald process. How do I know that? The Ostwald process forms nitric acid. Ostwald process. Let's look at 10.1.6. It says I must write a balanced equation for the formation, for the formation of fertilizer number B. A balanced equation for the formation of fertilizer number B. Let's go back here. So I can see that B occurs here. Let's see, we already found compound number A. Just want to use a different color. So compound number A was NH3. That's what we got. Process number 2, we found that it was the Ostwald process. This also works for me if you actually work on the paper. Ostwald process. Now I see, I need to form compound number B. So how will I then form compound number B? Using a balanced chemical equation. So this is how I'm going to do that one. The balanced chemical equation. Remember, for compound A, I was given NH3. I'm going to say plus. I've got HNO3. And then you have to you can either, so one of two ways. It's either you know how it will react and how it will form, or you have to know it prior to this. But remember, practice makes perfect. So nonetheless, looking at these two, I can see that NH3, HNO3 will then together give me the following. And how did I get this? This H will form with this H to change the NH3 to NH4, and I'll be left with NO3. So this will break into H plus, and this will be NO3. So this H right here will bond with that one, changing my number of H's from 3 to 4. So this will become NH4. And what do I still have? What do I have there? This is then NO3. So that is then the formation of compound number B. So question number 10.2. Now we are told that we've got a 20 kilogram bag of fertilizer, which is labeled as follows. Now, what does the ratio on the label represent? So I just want to, quickly, most of the time, they give you a fertilizer bag like that. So this is how, it's not really how a fertilizer bag looks, but I just want to show you because most of the time we are so familiar with what we are so used to seeing that if they wrote it any different, it might look completely different to us. So this is my fertilizer bag, and the question is asking me, what does the ratio represent? Remember, we've got 2 to the ratio of 4 to the ratio of 3, which represents my NPK ratio, right? So those ratio is my NPK ratio, my nitrogen, phosphorus, and potassium. Or you could have also said that is your ratio of primary nutrients. The ratio of primary nutrients. I just want to elaborate a little bit further on this, on the NPK ratio and why it's so important. So most of the time, if you are a farmer and then you see that your plants don't really look so green or your fruit doesn't really taste so nice, then we use fertilizer, right? But these ratio actually mean something. So when you're buying fertilizer, you must actually see what is the highest ratio in the fertilizer and what does that ratio actually help. Because sometimes the fertilizer is so great at making your plants green and they look so lively and juicy. Or sometimes it just really helps to improve the taste and the quality of the fruit and so forth. So this NPK ratio is very important because as a farmer, you need to know where you're actually struggling or where your fruits are actually struggling, and then you buy the correct fertilizer to improve those plants. So you need to know what the ratio actually means, how it actually structures, and how you calculate. Also, if you look at my screen, they've given us an X here. So this X tells us how much of this bag is then actually fertilizer. They've given us the ratio, yes, but how much of it is actually then fertilizer? Because sometimes you buy a whole 20 kilogram bag of fertilizer, but only to find that you only have 5 grams in that 20 kilograms, which is actually then fertilizer, right? So you also need to see in that 5 grams, is there a lot of nitrogen, phosphorus, or potassium? And then you're able to see what you then need. But these ratios are very important. They represent the NPK ratio. N is for nitrogen, P is for phosphorus, and K is then for potassium. So that is the NPK ratio, or the ratio of primary nutrients. Now remember, all plants need some sort of form of nutrients. Now, question 10.2.2 says the bag contains 2.315 kilograms of phosphorus. So what I would do here, I will write it here as NPK, so of phosphorus. So I can see that, phosphorus is over here. So this contains 2.315 kilograms. So can you already see? Out of the 20 kilogram bag of fertilizer, only 2.315 kilograms of it is actually phosphorus, right? So you can see that not the entire bag is actually fertilized, just a portion of it, and the rest of it is just then filler. So now let's see what the question is going to say. So they've already given us 1 to work from. Now the question continues to say, I must calculate the value of X. What am I calculating? I need to calculate what is this value of X. So how many kilograms is then there? So I found 2 ways in which you could have done it. I just want to expand my page. I'm going to need quite some space. So the first one that we could have done, I'm going to do it the long way around so that everybody is with me. I'm going to write it as we were given the ratio N, P, and K. And I was given the ratios of 2 is to 4 is to 3. And then I'm given an X over here. Now we know from grade 9, when you're working with ratios and you need to find the unknown of this ratio and so forth, the best thing to first do is to actually add those ratios, and then you're able to find the value of the ratio in those ratios. Doesn't make quite sense, but let me show you. So what I'm going to do is I'm going to say 2 plus 4 plus 3. So I'll find the sum of all of this. So 2 plus 4, that will give me 6, plus 3 will give me 9. Now I'm looking for X, but most of the information that I was given was for phosphorus because I was given the mass of it as 2.315 kilograms. That's how much I was given. So what am I going to do? I'm going to work with the phosphorus because that's the amount of information that I have. Therefore, I'm going to say, let me work here. I will then say 4 over 9. Phosphorus is a ratio of 4 and this total is 9. I'm going to multiply it by, I'm going to say X, right? Because that's unknown. And then I'm going to put it over 100, working at it as percentage. I want to go back to my fancy diagram over here. So I'm going to multiply it by the total value of the bag. Remember, I'm looking for the value of X in a 20 kilogram bag. So therefore, I'm just going to multiply this by 20 kilograms. And then for phosphorus, in the 20 kilogram bag, only 2.315 of it, 2.315 of it is then the P. So now I only have one unknown, and then now it's just mathematics. So let's see. I've got fractions, whole numbers. I'm just going to put this one over 1 so I can simplify this. Numerator times numerator times numerator. I'm going to try to do this one in my head. 4 times 20, 4 times 2 will give me 8, and I've got a 0, so that will give me 80x. Over 9 times 100, that should give me 900. That one was fairly easy. And I'm all equal to 2,315 kilograms. But now remember, I'm not done yet. I must still solve for x. If I'm working with a fraction on this side and a whole number on this side, I'm going to put this one over 1. And according to mathematics, I can therefore cross multiply. I'm going to multiply this with that, multiply this with this. I actually want to work it out, so I just put it in the calculator once. So I'm going to have 900 multiplied by 2,315. And I'm going to have 80x multiplied by 1. I'm going to have 80x, yet I'm not done. I'm still looking for the x by itself. Therefore, I can divide both sides with what is bothering the x, and in this case, it's the 80. So I'm going to divide both sides by 80. 80 and 80 in this side will cancel, because 80 divided by 80 is 1, and 1 times x is x. So let's put this one in my calculator, and then let's see what happens. Remember, I always remind my kids to always put brackets over around everything that you're using, so that you're guaranteed that your calculator will give you the same answer. Now, if you didn't do it like this and you kept rounding it off, most of the time the question paper will actually have a bracket of where you could have went wrong or what you could have gotten right. So here I get 26.04. Remember, we must always round off to 2 decimal places in chemistry and in physics. You look at the third number. If the third number is less than 5, so 4, 3, 2, 1, and then the number in front of it does not change. If the third number is 5 or greater, so 5, 6, 7, 8, 9, it'll change the number in front of it to its next value. So let me go out here. So I get 26.04. This will be 26.04, and this then will be kilograms. So that's the first way that we could have worked out this problem. I just want us to find another way that we could have worked it out. So remember, then again, I've got the ratio Npk. Now, you could have chosen anyone. I've got a ratio of 2:4:3. And I know that most of my information was given for the P, and I was told in the 20 kilogram bag, I've got 2,315 kilograms of phosphorus. Now, I'm looking for the mass of phosphorus, and I'm given 2,315 kilograms, right? That is the mass. Again, I'm going to add all the ratios. You're going to see how all of this is going to come to play. I'm going to say 2 plus 4 plus 3, and then I get 9. This part is mostly crucial in all the ones. So therefore, I'm just going to work here. I can say phosphorus is then equal to, remember, this is what I was given. I was given 2,315 all over 4. And this 4 is the ratio that I got there. And I can therefore find an answer. So now I want you to look carefully here. Can you see? Let me just get the answer first, and then it'll make it a little bit more easier for us. I've got 2.315, and that is all over 4. I'm going to write the whole decimal. So now I'm finding it as a decimal within this value that I'm given. So I'm going to write it down exactly as it is. Therefore, I get 0.57875. It's very crucial that you write your entire answer out and you only round off your final answer. Remember, guys, if you keep rounding off your answer to the next to 2 decimal places the entire time, it kind of moves you away from the bracket. What I always tell my kids is that if you're working with a long decimal, rather put it in exactly like that. Rather say memory plus on your calculator, and then you're able to plug it in exactly as it is in your next answer, so that you actually only round off your final answer to the 2 decimal places. Even though the examiners give you some form of a bracket, it's much more safer to do it like this. Or if you really don't want to write the whole thing, rather round it off to 4 or to 5 decimal places at maximum. But nonetheless, I found for phosphorus, this is the mass I'm given for phosphorus over a ratio of 4, and then I found this value. I'm going to do the same for N. Even though N is unknown, I'm going to use mole ratios. So I found the value of 1. So 2,315 divided by 4 gives me this because there's 4 of these values in there. So I'm going to use stoichiometry again from chemistry. So I can say 1 of this times 2 for nitrogen since there's a ratio of 2 in the bag. I can use this value multiplied by 3 for potassium because there's 3 of them in a bag. Just want to elaborate a little bit further. Remember when we do stoichiometry, especially chemical equilibrium and so forth, then you have to use mole ratios. If this is 2 and this is 1, you must find the value of 1 mole and then you're able to find the value of any of the other moles in the equation. So this is technically what I'm doing. So what I decided was, since I'm given the mass of phosphorus as 2,315 and the ratio is 4, I'm going to find the value of 1, right? Since all of them are ratios anyways. So for nitrogen, I'm going to use a 0,57875 and the ratio in the bag is a 2. So I'm going to multiply that by 2. So I'm going to have this value here exactly as it is. I'm just going to multiply it by 2. And then I get that whole answer again. I'm going to write the entire thing. I'm not going to round it off. I got 1,1575. And I'm going to do the same thing with the K. Remember, phosphorus gave me most of the information. They've already given me the amount of that there is of fertilizer in the 20 kilogram bag, which was 2,315. It is a ratio of 4, so I'm finding the value of 1 ratio so that I can find all of them in the bag. My K, my potassium, is a 3. I'm going to take this value over here, multiplied by 3 so that I can find the ratio. 0,57875. I'm going to multiply that by 3. Let's see what we get there. I'm just also going to put it in brackets, 0.57875. Let me just see if I wrote that right, 0.57875. And I'm going to multiply that by 3. Let me just go backspace there. There we are. And that is the number that I get. Again, I'm going to write the entire number, not rounding it off. 1,7362 and then 5. Now that this is now what I have for each and every ratio, I've used this one to find all the other ratios for them. The mass of this one was already given, so now I can find my total mass. I'm just going to go down a little bit so I can say my total mass. This one has a bit of a long method, but it's also pretty safer. And remember, my ratio is given, let me write it here, Npk. So now I've found the value of each and every ratio in the bag. So my N was 1,1575 plus my P was 0,57875 plus my K was 1,73625. Let's see what we get there. We are almost there. Not the final answer, but almost there. The first one is 1.1575 plus 0,57875 plus. The last one is 1.73625. And then I get that answer. Let me see if I'm adding it wrong. I just want to add this one quickly here. With this one, we're going to add these ones, but for this one, we've already given the mass. We're already given the 2.35. There we are, 2.315. Yes, as you can see, it cannot be less than all of these ones because it has the highest ratio. So I used this one to find all the other masses. I found this one, I found this one. For P, it was already given. I just used it to actually use stoichiometry to find the rest. So I'm already given with this one. So let me just add that properly. So then let's try this again. 1,1575 plus 2.315 plus 1.73625. There we are. Then I get that entire answer. Again, I'm going to write the whole thing so that I only round off my final answer. Therefore, I find this as 5,20875 kilograms, but they're still looking for X. Remember, this is just telling me how much fertilizer now we have in a bag. We are then one step there. So now to find this one, I'm still looking for X. right? I just want to go back to my nice diagram over here in my previous slide. I just want to go back to this diagram. Remember, now that we found the value of each and every one, right? I'm still looking for X, but all of these values of fertilizer are in a 20 kilogram bag. So I must still find out, already I found the grams of them one by one, but how much of this is in a 20 kilogram bag? So that's the only way I'm actually going to find my X. Therefore, I can say my X, I'm going to say my 5,20875 all over the mass that I'm working at is 20. I'm going to multiply that by 100 so that I can therefore find the mass present. I'm going to put it in my calculator exactly as it is, 5.20875 all over 20, and I will multiply that by 100. Aha, and there we get the same answer. I get 26,04. Remember, the third number will not change the 4 because it's less than 5. Therefore, I get 26,04, and this is in kilograms. Just want to go through this step quickly. So for this one, the crucial thing was I used the ratios that I was given. I had most of the information for my P. So now, the one thing that we had to do was use stoichiometry. Now, I know we're very good with stoichiometry already. So I'm going to use this stoichiometry of P to actually help me find the value of each of them. So I found the value of 1, which was 0.57875, and therefore I was able to multiply it by 2 so that I can find the value of the nitrogen in each one. And therefore I was then able to find the mass in each one, so that's in kilograms. I was already given the mass of P, and this is the 2.315 that I already had. So me finding the individual mass of each of the ratios that were given in the fertilizer, I was able to add everything together, which means in the 20 kilogram bag, 5,21 technically, kilograms will then be my Npk ratio. However, I want to find the value of X. So this means if this is my fertilizer in a 20 kilogram bag, I can then multiply that by 100 to find my value of X, which is 26,04. Whereas in this one is a little bit shorter, but a little bit confusing. Here's the bag that you're given. You also need to find X, and this was just mathematics. So I added up all my ratios. I took phosphorus because I took my P because that's the one we have the most information. So it was 4 out of a ratio of 9 multiplied. I'm looking for X, you take it as 100, multiplied by 20 kilogram bag. I do know that only 2.315 of it is actually fertilizer. And then what do? If you have only one unknown in mathematics, then you are able to solve it. Cross-multiplied, and then I again found 26,04. As you can see in both equations, I didn't round off my answer to the nearest decimal places in every single time. I managed to actually try and plug in everything all at once in my calculator. That's why I got my answer exactly the same in both sides. This one is a little bit tricky, but you'll see as you keep practicing, you get better at it. And if you are still struggling, rather do it the long way around on the one that I showed you on method number 2. It's a little bit long, but it's also very accurate, and it actually makes sense.